Hello, we are Design Group 3, and we will be presenting the design specifications of our rehabilitative exoskeleton device. Immobility is a burdensome condition that affects more than 100 million people a year and can lead to costly complications. Traditionally, patients with physical impairments go to rehabilitative therapy to restore function. However, the excessive cost and lack of rehabilitative specialists are factors that affect adherence to these programs. Alternative approaches must be considered to lower costs, lessen the demand on rehabilitative specialists, and improve access to care. One way to address these challenges is through at-home therapy that uses robotic exoskeletons, which are wearable devices that enhance physical performance. This approach relies on assist-as-needed algorithms that use sensors to determine when patients physically need help to complete therapeutic exercises. In order to design the problem statement, a questionnaire survey was administered to 18 people regarding assist-as-needed exoskeleton devices. The general consensus was that these devices for rehabilitation can be uncomfortable, heavy, rigid, bulky, and expensive. To increase patient care and comfort, exoskeleton devices should be redesigned to be more lightweight, user-friendly, and inexpensive. Benefits of this redesign would lead to increased access to care at a lower cost.
The current gold standard in the exoskeleton market is the modularity concept for usability and personal use. This concept allows for more flexibility and variety in the device through the addition of more degrees of freedom. There's a currently growing need for medical and industry-related purposes since industries want to support employee health along with boosting productivity. Meanwhile, there is an increased amount of spinal cord injuries and other medical disorders that negatively impact limb movement. The current products in the 2022 market have a size of $334.5 million and 11,333 units, and the prominent companies include Exobionics, Hokoma, Lockheed Martin, SuitX, Rex Bionics, RB3D, Rewalk Robotics, Cyberdyne, and ActiveLink. These companies all make different kinds of exoskeletons, where some designs are wearable body robots, whereas others are more focused in specific areas of the body, such as the arm, wrist, and leg. There's a large range of current products out there in the exoskeleton market. Through further market analysis, it was determined that the mobile exoskeletons dominated the market with a share of 61.1% revenue and 62.2% volume in 2022, and the rest of the market is fixed or stationary devices. Since there is an extreme and growing need for more advanced medical devices for the aging and disabled population, there is an upward trend in the exoskeleton market as reflected by the figure on the left side. In this figure, it reflects the split in the market between mobile versus fixed exoskeletons in the United States only. Meanwhile, in the figure on the right, it shows how global exoskeleton markets is split into three, where the majority of the usage is in healthcare, followed by the industry and then military. The global exoskeleton market size was valued at $257.9 million in 2021 and is projected to grow by 18% from 2022 to 2030, and this is reflected in the pie chart figure on the right.
A survey was sent to 18 users and potential customers to learn what they valued as the most important characteristics of the exoskeleton device. The survey questions asked are listed here on the slide, asking about things like cost, training processes, comfort and restriction of the device, and noise level of the device. From the results, level of comfort, cost, and level of restriction were the most important characteristics for the users and potential customers. The first device we performed competitive benchmarking on is the Myomo MyoPro device. It is an exoskeleton device to help restore function in the arms and hands to assist in daily activities. This device is most similar to ours as it is the only marketed device currently on the market. The MyoPro entered the market in June 2017, so it is still relatively new. The cost is around $10,000. However, it is covered by 7 major insurance companies around the United States. The strengths of this device are that it's custom fit to each customer, minor adjustments can be made to optimize comfort, insurance covers the cost, the device is quickly ready after the fitting, you can use it independently after the training process is complete. The weaknesses of the device include that you have to go through training in order to obtain the device, it is expensive, There is an extensive process to be approved for the device. Insurance approval takes months, and that is only for patients over the age of 12.
The second device that we looked at was the Shoulder X by SUIX. This is a bigger exoskeleton that people wear on their body, and it features an adjustable support to accommodate different users for varying needs. While using this device, the support force increases as the arms are lifted and becomes near zero when it is lowered to allow for natural resting and reaching for items. The product fits most individuals without needing for further parts. This product entered the market in March 2019 at a market price of $4,000. And some strengths of this product is that it has significant reduction to user fatigue, overall muscle activity and risk of injuries, does not require additional hardware or tools to adjust the size or strength. No batteries are required so the device can be utilized for extended periods, conforms to the unique body shape of each user. Adjustments can be made to optimize performance for any task, minimally inhibits arm and torso motion range so it is more comfortable. Some weaknesses of this product that it is large in size. The exoskeleton covers the back and the upper arm. It is designed to improve support for work in the industry rather than also including daily living activities. It is meant to reduce strain and loads instead of improving arm functionality. The total weight is 7 pounds, so it can be heavy over time for some users that need additional shoulder and arm support. The next device that we looked at was the Carbon Hand, and this device provides enhanced hand function and improves weak or unsteady grip through sensitive pressure sensors in the glove's fingertips that allow detection when the user grabs an object. It is an assistive aid for activities of daily living as well as doing work. And the features of the Carbon Hand includes how users show significant improvements in grip strength and hand functionality through the usage of this. Different grip profile settings can be adjusted to the user's personal needs, and the device is available in many sizes and cable lengths to fit the user. This product entered the market in October 2020 with a market price of around $7,000. However, the additional glove components sell for about $550 and must be replaced every 6 months. Some strengths of this device include significant improvements in grip strength and functionality through several weeks of usage by reinforcing the hand functions and adding extra strength when needed. Adjustable fit for user needs through grip profiles, size variety, and cable lengths. The device is light as total weight is approximately 700 grams. It functions similarly to our own hands through sensitive pressure sensors. Power is adjustable depending on weight of the object. All customization is simple by using a smartphone app. Batteries are rechargeable and can be utilized for both daily activities and better hand function at workplaces. Meanwhile, some weaknesses that it is expensive since the base product costs around $7,000, and there are additional fees over time since the glove components are replaced every 6 months for $550.
After benchmarking these competing products, there are competitive advantages for this device when compared to others. A lot of devices on the market are used more as a brace rather than an exoskeleton device that moves on its own. Our device will be rechargeable to be able to be charged at night to last all day. The process for obtaining the device will be simpler than other devices. This was the biggest complaint about the MyoPro device. This device will be easy to take on and off, and the user will not need assistance in doing so. Some devices currently on the market are too bulky and large to take on and off without help from others. The patients and users for this device can be of any age. This is the least important advantage since many of the patients are not of the younger ages.
We looked at a series of existing patent literature as well, with the most relevant being a soft and wearable glove design, as shown, which allows for a more user-friendly and comfortable device for the user. It includes sensors on the glove that can detect the damaged area of the extremity and uses position feedback to assist as needed. The patient controls most of the movement, which is the main strength of this design. The second patented design relevant to our device was the soft polylimb system. It is wearable by the user via a backpack mount to provide enhanced object manipulation to the user. The flexibility of this design allows for the exoskeleton to be more comfortable and adjusted according to each patient's needs. The third existing design found was the exoskeleton for assisting human movement. Like the others, it is wearable and has up to 7 controlled degrees of movement per limb, ensuring user equilibrium. It can be fitted to each individual patient without requiring a functional transfer.
As mentioned a couple of slides before, we utilized a survey to ask customers what they thought about current available options in the exoskeleton market. After survey results were gathered, the answers were determined to be either positive or negative. Negative answers to the survey questions were categorized as such because there are issues with current iterations of the device. Those answers are seen here in the Pareto chart that was created from the negative survey results. The most pressing of the negative qualities found in current iterations include the comfort, cost, and the lag time that is experienced between user input and movement of the device. Comfort in the shoulder and elbow is especially important, as it accounts for nearly 85% of comfort issues, and comfort issues clearly dominate every other issue. The positive results are seen in slide 16, and they were categorized as positive because these qualities are found to be adequate on current iterations. The least problematic of the qualities can be seen in this slide, and some of those include copay price and the lack of restriction when the device is not in use but still attached to the arm.
Like previously stated, the Pareto chart was a great tool for analyzing our survey results. This gave our team direction in coming up with our customer requirements. We had a brainstorming session while working on homework 3. This consisted of us using a whiteboard to organize our ideas and categorize what design characteristics are similar and what can be grouped together. This led to the customer requirements shown in this next slide. As shown, we came up with 8 customer requirements, such as level of comfort, cost, and strength of device. Narrowing down their descriptions also took a little brainstorming session between a few of the group members, and they are provided here as well. The customer requirements led to the creation of the engineering characteristics, which are similar items, but the engineering characteristics consist of more technical wording. The tables have similarities, and they are analyzed using another problem-solving tool later in this presentation. But first, we will review the constraints. The possible design constraints are listed here. We've included a resource constraint, which is about the battery life and rechargeability of the battery. This constraint will be further narrowed down during device testing. The next constraint is the user-friendly constraint, which is about controlling the device by the patient or patient's caregiver. For example, putting the device on the patient and taking it off the patient. The last constraint is the electrical constraint, which is about the safety of the electrical current flowing through the device. For example, a limit needs to be set on the current to ensure components will not heat up significantly during use. This constraint will also be further defined through device testing. As of now, there are no constraints provided by the FDA. Here's the house of quality, which is used to compare the customer requirements with the engineering characteristics and review their accuracy. As depicted, we weighted the customer requirements by the importance provided through the survey results. We then used relationship comparisons in order to mathematically calculate the score of each engineering characteristic. These scores were used to rank the characteristics and determine the 5 key characteristics, also known as the design characteristics. The correlation between engineering characteristics is also shown at the top of the diagram and indicated as positive or negative by the plus and minus symbols. This shows the 5 design characteristics based on the house of quality results: adjustability, exoskeleton range of motion, weight distribution, minimal grating and motor noise, and material cost.
The functions of this device are shown here in the function structure. The person reaches for the object they want to pick up and grabs it. The person then attempts to move the object. Once the person grabs the object, the device measures muscle activity from the signals. The device then converts electrical energy to mechanical energy. The object moves according to muscle signals received. Potential energy is now kinetic energy. The person then changes direction with assistance from the device.
This brings us to the last part of the report, which was the feasible concept. The first of these 3 takes adjustability into account, and not only does this impact the option to customize the device to fit individual patient dimensions, but it also influences the cost of materials, distribution of weight, lifting capacity, and possibility of noise within the device. The device requires an attachment point to the patient's torso to help ensure stability of each joint within the arm, and this is currently achieved through the use of a bulky vest-like attachment. This is not ideal though, as it is heavy, unwieldy, and difficult to put on. A backpack designed for the attachment point would allow the patient to easily slip the device over their shoulders and adjust for comfort with multiple straps around the waist and chest. However, in exchange for a device that is easier to put on, the patient could experience a lesser range of motion about the torso due to the nature of the straps. The next concept also seeks to improve adjustability. Current designs utilize custom orthotics for the padding of the tricep and forearm areas, and although this works, it is very expensive to be fitted and cannot be reused for different patients. This concept uses air casts to press around the patient's arm, providing a tighter fit and a more customizable fit. This allows for greater adjustability of the device as the patient can increase or decrease the air pressure using their available hand. Bladders to hold the air pressure are inexpensive and conformable with differential air pressure, meaning material cost is lessened from that of custom orthotics, and a one-size-fits-all concept can be adopted as the air pressure can be adjusted to the size of any patient. In addition, air is a compressible fluid, allowing for slight compressibility within the device and a better comfort. As with the air cast and walking boots, there is a risk of using too much air pressure and breaking the air bladders of the pump, but they are easily replaceable if this were to happen. The third concept involves reducing material noise and cost. Current exoskeleton designs use Velcro straps to secure the device to the patient, which can become problematic when you see the strap must be replaced frequently due to the nature of how it is used in an exoskeleton. With the stainless steel mesh and magnetic attachment point, almost like that seen on an Apple Watch, initial material cost for the straps becomes greater, but the increased durability means that the straps do not have to be replaced from patient to patient. It provides greater adjustability as it can be fine-tuned to fit any size, and it also reduces noise from the device as the noisy rubbing of the Velcro material can be annoying. These stronger mesh straps will conform to all parts of the arm where they are placed and can be easily adjusted one-handed. These magnetic stainless steel mesh wraps are more durable and will last longer, be easier to clean, and if aesthetic is important, provide a sleeker look to the device.